In this forest ecosystem, survival comes down to a brutal equation: mass and muscle. Heavy predators rely on raw kinetic energy to dominate. Little ant occupies the absolute bottom of this hierarchy. He lacks the physical mass to pull a simple grass cart without it collapsing, making him an easy target for the mockery of larger predators like toad and fox. So how does a creature with practically zero physical strength survive in a world built on brute force? And how does he realistically plan to leave that world behind and travel to the moon? Competing on the terms of mass and muscle is a dead end for the small. To survive, you have to throw out the rulebook and operate on an entirely different set of principles. Inside Teacher Elephant's STEM classroom, the rules of the forest are replaced by the laws of physics. Here, the focus is on force multiplication, using geometry and mechanics to generate massive power with minimal physical effort. Little ant relies on force multiplication. A downward push on a log lever multiplies a class of fulcrum to easily hoist an elephant. Similarly, water molecules bond into a flexible skin supporting his tiny mass, while heavy predators break the bonds and sink. These principles effectively rewrite the power dynamics of the forest. When you can manipulate the environment through physics, physical size becomes a manageable variable rather than a life sentence. But the ambition to reach the moon means facing the ultimate heavyweight bully, Earth's gravity. You cannot muscle your way out of the atmosphere. The team builds the Nano Voyager using a superalloy that fuses iron and aluminum with carbon nanotubes, structures as hard as diamond. This creates a hull that maintains its integrity under the full weight of a predator's stomp, while keeping the ship's total mass low enough to launch. To counter the gravitational pull, they rely on a hydrogen fuel engine. By igniting hydrogen gas, rapid combustion forces high-velocity exhaust out the nozzle. That downward action generates the immense upward thrust required to break free of Earth. This orbital map shows how they bridge the 238,000-mile gap. Instead of flying in a straight, fuel-draining line, the ship follows a Hohmann transfer orbit. This specific elliptical path uses the gravitational momentum of the planets themselves, maximizing fuel efficiency to reach the lunar surface. Leaving the planet requires a precise orchestration of materials engineering, chemistry, and orbital mechanics. Once they land, the moon presents a brutally hostile vacuum. The surface swings from 120 degrees Celsius in the sunlight to negative 130 degrees in the dark, swept by abrasive, static-charged dust storms. When a storm hits, Little Ant exploits the moon's low gravity, just 1/6 of Earth's, to easily haul massive metal plates. Using a concentrated laser tool, they quickly weld these plates into an airtight thermal shelter. But the environment isn't the only threat. They are quickly cornered by spiderbots, automated lunar security machines equipped with heavy armor that physically outmatch the animal crew. This schematic breaks down their defense strategy. Squirrel and Wolf jury-rig their damaged solar panels, funneling the residual electricity into a scavenged amplifier. They triggered a massive, concentrated burst of electromagnetic energy. Watch the system nodes as the wave expands. When the electromagnetic pulse strikes the spiderbots, it induces high-voltage surges directly into their hardware, instantly scrambling their circuitry and shutting them down. Without striking a single physical blow, applied physics outmaneuvers advanced weaponry. The final obstacle is colossal. A 3-story-tall liquid crystal entity emerges from a crater, demanding the return of the olivine energy stone they discovered. Wolf transmits a radio signal based on the Fibonacci sequence: 1, 1, 2, 3, 5, 8. By plotting a sequence that mirrors the growth patterns of shells and galaxies, the crew establishes a shared mathematical logic with the entity. But the message takes time to process. While the giant observes, a swarm of smaller crystal guards suddenly charge, violently hammering the hull to breach the cabin. The crew counters with acoustics. They calculate the exact resonant frequency of the guard's crystal lattice and blast a 20 kHz ultrasonic wave. This chart maps the attack. The vibration forces the crystal molecules to shake, stunning the guards. But notice the red danger zone. Pushing past 25 kHz shatters their own ship. It's a precise threshold, capped to ensure survival. The giant entity observes this exact calculation. Recognizing their restraint and intellect, it halts the attack and grants them the energy stone. Returning home presents one last physical barrier. As the Nano Voyager hits Earth's atmosphere, the friction of compressing air ahead of the ship superheats the exterior to 1500 degrees Celsius. The carbon nanotube superalloy absorbs the initial shock, while an active water cooling system continuously bleeds thermal energy away. The temperature stabilizes, the parachutes deploy, and the ship touches down intact. Back in the forest, the power dynamic is reset. The predators who once mocked little Ant now stand in silence, watching the tiny crew disembark from a vessel that reached the stars. From walking on water to communicating with the cosmos, these lessons in science provide the lift needed to leave the forest floor. They are the pair of wings that turns an impossible dream into a reality.